This is question number 2 of exercise 5.5 from the chapter Continuity and Differentiability. Okay, so we have to differentiate with respect to x square root of x minus 1 into x minus 2 upon x minus 3 into x minus 4 into x minus 5. So here I would like to make a point that when we have a large number of functions multiplying as here, then we can solve this function, or that is, we can differentiate this value easily by applying log. Okay, so you have to keep in mind that whenever such type of functions are given to us, so log would be an appropriate method here. Now to solve this question, first of all we take the value as equal to y, and we are going to further take log of both sides of the equation. So I'm going to get log of y is equal to log of square root of x minus 1 into x minus 2 upon x minus 3 into x minus 4 into x minus 5. And we know that log of m to the power of a is equal to a log m. Okay, so this value inside the square root can be considered this whole value to the power of 1 by 2. Okay, so I can write this as equal to log y is equal to 1 by 2 times log of the value inside the square root. Okay, and this value can be simplified very easily and written like this. So you have to just make a point that if we have certain values, or if we have a fraction and fraction has some factors, and in the numerator and in the denominator also, then the factors in the numerator are written as log of x minus 1, log of x minus 2, and in the denominator are written with negative sign. So that is why I get log of x minus 1 plus log of x minus 2 minus log of x minus 3 minus log of x minus 4 minus log of x minus 5 as the value of this log value, and this 1 by 2 as it is and log y as it is. Okay. Now we are going to differentiate both sides of the equation with respect to x. So I'm going to get d by dx of log y is equal to 1 by 2 times d by dx of log of x minus 1 plus d by dx of log of x minus 2 minus d by dx of log of x minus 3 minus d by dx of log of x minus 4 minus d by dx of log of x minus 5. Okay. Now differentiation of log y as done in the previous question can be written as 1 by y dy by dx. Okay, and here I'm going to apply the chain rule of differentiation to differentiate log of x minus 1. So this would be equal to 1 upon x minus 1 into d upon dx of x minus 1. Okay, this would be equal to 1 upon x minus 2 into d by dx of x minus 2. So this would be equal to similarly 1 upon x minus 3 into d by dx of x minus 3. This value would be equal to 1 upon x minus 4 into d by dx of x minus 4 minus 1 upon x minus 5 into d by dx of x minus 5. And on differentiating x minus 1, I'm going to get 1 differentiation of x minus 2 would be again equal to 1. That is, differentiation of all these values would be equal to 1, because differentiation of x would be 1 and differentiation of constant would be equal to 0. So I'm going to get 1 by y dy by dx, this term as it is, which is written on the left hand side, and this is equal to 1 by 2 times 1 upon x minus 1 plus 1 upon x minus 2 minus 1 upon x minus 3 minus 1 upon x minus 4 minus 1 upon x minus 5. Or in next step I'm going to cross multiply this y and write the value of y, which I have assumed as equal to square root of this whole value, and dy by dx would be equal to 1 by 2 square root of this value minus 1 upon x 1 upon x minus 1 plus 1 upon x minus 2 minus 1 upon x minus 3 minus 1 upon x minus 4 minus 1 upon x minus 5, which is the required answer. Friends, thanks for watching my video. To watch more of these super videos and for the latest updates, subscribe and like the videos on these channels on YouTube, HSK Shiksha and Math Help by HSK. Thank you.